Sending a Vectron to outer space is an idea that we've actually had for a really long time.
Being successful with this task was no small feat. It took about 4 months worth of research in order to model the actual craft flight properly.
But it was the complexity of the gear within that box, the flight computer to register how high we went, and the distance we traveled, the GPS, so that we could actually track it down, the radio receiver, which was kind of like our backup secondary track it down type of thing. That little yellow box was packed with everything, including 2 GoPros, extended battery packs, because this thing could be up there 2, 3, 4 hours, and it could be even longer by the time we found it.
We had to think everything through because we only got one shot at it.
There's a whole series of things you have to do to actually make things work at altitude as well.
I suppose in my mind, I thought that technology would work perfectly the whole time. We get GPS tracking, we know exactly where it went. We're using predictive models.
It takes about 3.5 hours from launch to land.
Route 66, we launched right off the side there, pulled off onto a dirt path, and then proceeded to follow a very strict process. Of critical importance was using very sophisticated weather predictive models to say, if we launch at this time, on this day, how high will we go, where will it land?
In order to get the right altitude, making sure that the balloon will burst, you fill the balloon with a given quantity of helium, and it's roughly 6 feet across on the ground. The actual balloon expands to a diameter of roughly 30 feet. They actually rupture, and that's what brings the balloon back down. When it goes up, you lose the GPS location at 50,000 feet.
Finding this thing, I expected it to be easier than it was. We have all of this great technology in play. We had GPS in there, we had radio transmitters, we had backups, and what ended up happening is a situation where this thing landed.
It was upside down, so we saw it coming down, and then the signal died. We expected to actually get a few more indications of where it was when it landed, but it just stopped it pretty much mid-air.
That's right.
The most difficult part of doing something like this isn't actually the launch, it's the recovery.
The engineers were back with the trucks, tracking this and tracking us. We had to put a GPS on our ATV so they could literally guide us to this thing, to the rig, and it was, in theory, again, it was great. The rig tilted over. When that happens, the signal gets lost, the satellite can't connect with it. And then all of us kind of thought, if the wind could blow it, how far could it blow it? And we started searching in an entirely new area, hundreds of meters away from where the last GPS signal was, and it was a bit of a gamble, because it was starting to get a little late, and we found it.
And there it is.
We're trying to do stuff that's never been done before, and that's a tall order for toys.